Alright guys, today we're going over 12-2 Fundamental Counting Principle and Factorials on page 332. Our objectives here are to use the Fundamental Counting Principle to find the size of a sample space, and then to use Factorials to find the size of a sample space as well. Okay, so you use tree diagrams and or the Fundamental Counting Principle to find the size of a sample space. So for instance, if you have vanilla, chocolate, pistachio, and mint ice creams, so 4 different types of ice cream, okay, and 2 different types of sprinkles. You have regular or cinnamon, okay. If we use the Fundamental Counting Principle, we just multiply our numbers there and get 8. So there's 8 total different combos that we can use there. If we use a tree diagram, we set it up like this. So we have types of ice cream where it's vanilla, chocolate, pistachio, mint, and then after each ice cream, we're going to add on there either if it's regular sprinkles or cinnamon sprinkles. So we add all these up. We have 1, 2, 3, 4, 5, 6, 7, 8. So either way you do it, you're going to get the same result. Okay? Obviously, you're going to use a tree diagram if the numbers or the sample space isn't super complicated. If it is, then that's when you would use the Fundamental Counting Principle like we did over here. Okay? Alright, so the example we did in class is the example that's on page 332 where it has the rye bread, the wheat bread, grilled chicken, turkey, and then Swiss, cheddar, and American. So you need to copy that down, that tree diagram that's on page 332 in your notes. Okay? Alright. Okay, now we're on to factorials, which is a factorial is an expression represented by a number with an exclamation point after it. And it's a product of all positive integers that are less than or equal to the number that is in n's place. So if we had 3 exclamation point, it's going to be 3 times 2 times 1. Whoops, that's negative 1. I'm going to rewrite that. Okay, so 3 times 2 times 1, you end with 1. So you start with the number that is before the exclamation point, and you end with 1. So it's the list of, or it's the product of a list of the decreasing consecutive numbers that ends with 1. Okay? Now it was 0, so we multiply by 0, then your product will be 0. So 3 times 2 times 1 is going to give me 6. So the factorial for 3 is going to equal 6. Okay, the factorial for 5, same exact thing. You start with 5. So 5 times 4 times 3 times 2 times 1. 5 times 4 is going to be 20. 20 times 3 is going to be 60. 60 times 2, so we have 20. 20 times 3 is going to be 60. 60, oh, come on, pencil, work for me. 60 times 2 is going to be 120. Okay? So the expression for 5 factorial, that's how you pronounce it, is 120. Erase this bad boy. Okay? So I want you to do 7 and 11 on your own. If you need to use a calculator, that's fine for quicker results. Okay? Good luck. Okay, so if it's 7 factorial, your answer is going to be 5,040. If it is an 11 factorial, it's going to be 39,916,800. Seems like a really big number. I totally get it, okay? So remember, when you see anything like a number with an exclamation point, this would mean 6 factorial. Okay, so this would be 6 times 5 times 4 times 3 times 2 times 1. Okay? Alrighty, we use factorials to find the number of different ways a group can be ordered, any kind of group. So if we're looking at how many ways can a group of 10 friends stand in a row for a picture, how many different ways can they, right? So that's when we would use the Factorial Method. So we would do a factorial of 10, like this. So that would be 10, 9, 8, times 7, times 6, times 5, 4, 3, 2, 1. Okay? Let's do that all together. Which would actually be 3,628,800. Okay? So if there were 10 of you in a group and you wanted to have 10 different versions of it, you do a factorial of 10, multiply 10 all the way down to 1. So this is the possible number of outcomes that you would have if you had 10 different people standing in order 10 different ways. Okay? Alrighty. The second thing we're going to work on is expressions with factorial. So if you had 6 factorial over 3 factorial would look like this. Okay, so we're going to have 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. So before you start multiplying these bad boys, I'm going to try and simplify them. Okay? So we have, let's do this. I have a 2 here, and a 2 here, so it goes down to 1, goes down to 1. I have a 3 here, and a 3 here, 1, 1. So now all I do is multiply. On the bottom here, I have 1 times 1 times 1 over 1. And then up top we have 6 times 5 times 4 times 1 times 1. So 6 times 5 is 30. 30 times 4 is going to be 120. Just double check that. So we have 120. Okay? So the 6 factorial divided by 3 factorial is going to equal 120. You don't have to simplify. That's my suggestion so that the math is a little bit easier. Especially when you're dealing with like 11 factorial or 20 factorial or 9 factorial. It's a lot easier. Okay? Alright. Finish up your notes. And I'll see you next time in class. Bye, guys.